All right. Hello, everyone. I know it's late. It's 5. It's Thursday. You guys want to get drinks. So thank you for coming. This is going to be great. My name's Leif. I'm a RenderMan specialist, which means I know a little bit about RenderMan, probably a little bit more than I should. And I have a commercial background in television and commercial as a CG soup and a CG generalist. So I'll be talking a little bit about RenderMan in a historical context slightly, and talk about the past, the future, where we're currently at with RenderMan and XPU. And we'll wrap a little bit about educational kind of resources and learning about RenderMan. Now, I got 3 walking teapots here. Who knows what these are? Yes, good. So a first show of hands. Who's ever heard of RenderMan? Okay, that's not bad. Who's ever actually rendered with RenderMan? Okay. See, the math doesn't work. Who knows the teapots? Who's actually worked with it? That doesn't. The numbers aren't adding up there. So, so I want to start by showcasing the amazing work that our partner companies do, our customers do. So, without further ado, let's get the show reel going. So let's give our studios a round of applause. I think they deserve it. We're very lucky to have them. They really give us, you know, that fuel that we need to kind of keep the render at its best. Their feedback and ambitions are always what really makes a render kind of shine. A little bit of history for those of you that didn't raise your hands. RenderMan has been around since 1988. It's pioneered the VFX industry as we know it by rendering the pixels in The Abyss, Terminator, of course, Jurassic Park, and all those Toy Story films. Back then, RenderMan had a kind of main algorithm that was called the Reyes algorithm, which stands for Render Everything You Ever Saw. And if you want to win a teapot, maybe you should be attentive to these details. So now we have a new framework. It's not Reyes, it's called RIS. And it responds to a different set of kind of, you know, needs from the industry. Back then we were trying to solve, you know, how to render an image with very, very, very little memory and very little processing power. That changed. Of course, we have a lot of access to memory and CPUs. We developed RIS for that. Currently, we ship RIS and we ship XPU. And XPU is in its development form. We're going to talk a little bit about the past, present, and future of XPU. And XPU also responds to this notion of where is the industry going. can we meet the hardware 10 years down the line and expect things to align properly? And you know, we've really made these concerted efforts to make sure that XPU is aligned with the hardware. So when we're truly production ready, you will have these massive cards with a lot of CUDA cores and massive amounts of memory. You'll be able to fit all kinds of amazing shots in the GPU and take advantage of XPU. Our previous version, RenderMan 25, was really a great kind of closure for look development and all kinds of great features for that. In the future versions, you know, we still have a lot of things to accomplish in this next year and a half. Display and sample filters, Material X layering and Llama, you know, stylization, deep data, Cryptomatte, all kinds of fundamental things for final pixel rendering. So with the past and future kind of outlined, let's talk a little bit about RenderMan version 26, which just released on April 8th. And we're releasing a first patch any day now. So we're really happy about that stability patch to complement the greater advancements in version 26. 26 is all about, you know, kind of taking look development further and giving artist tools the ability to actually generate full shots, you know, not only in key lighting, but in shot lighting with light filters, adaptive sampling, and more. We've also made some really amazing core optimizations for instancing and massive amounts of data sets. Latest 3D apps, you see, you know, just the improvements. And we also have something for RIS, which is our current production render, which is the interactive denoiser. And for those of you who don't know about our new denoiser, it's machine learning. It's trendy because it's AI, and we train it on all kinds of amazing Pixar imagery. It's been pretty revolutionary for us. It's allowed us to cut render times just absolutely drastically. Average frame sample counts for a frame in a Pixar movie now is around 60 to 70, which is amazingly small. ILM is about 200, which they used to render to full convergence to 1,000 or plus samples. So, and when you see these kinds of result and temporal quality of animation, you start thinking, well, if it's so good, why do it a post-process? Why not just kind of do it interactively for the artist? And that's exactly what happened. We saw that the denoiser was so good in low samples, 2, 4 samples, that you could really bring it in an interactive session much, much earlier and benefit the artists. So in our very first launch, we're actually tooling it for Katana and Blender, and we're working super hard to bring it to Solaris this year. And we're excited to kind of merge that gap with USD and Solaris workflows. Parallelism improvements is just a fancy word to basically say we've really improved RenderMan to render lots of things or to bring in data for massive amounts of data sets. So particularly instances and massive amounts of textures in the hundreds of thousands, for example, or in the tens of millions with instances. At the most extreme example, we see like 300x increases, but in the more typical workflow, you see a 10x or 20x increase in how fast you can see that first pixel. And just to kind of show that in some visual context, I'm a very visual guy. So this is R26. It's starting up and reaching my convergence metric before R25 even starts up. So those are the kinds of artist workflow speedups that are really interesting. And XPU advancements is really where all our core development is currently. And 26 shines for that. This is one of my favorite features, interactive progressive pixels, which is basically gives you the tooling to actually say, do I want a coarser or finer image, and how that affects my frame rate, basically, and giving you the power interactively as XPU updates the entire frame instead of doing the old school bucketing systems. Another amazing thing I was touching on earlier was adaptive sampling, which really allows us to cut down render times, by 400%. So before, XPU needed a target kind of sample, 1,000 samples. When you reach that, just kind of do it homogeneously across the image. Now we can tell RenderMan, you figure it out. I'm going to give you a variance metric, and I'm going to give you some min samples and some m's. So that's pretty exciting stuff. So right here, this is an image with the Crocostrich, famous from Victor Bessart. And well, I'll talk a little bit about how to get that asset in a second. But we're starting to see here in R25, our previous version, how we're bringing in volumes and depth of field and all kinds of goodies in this image. You can actually finally render a finalized image in XPU and denoise it. With R26, we're bringing in all kinds of amazing tools, for lighting. So Art Director comes in and says, well, you know what? I want these areas to kind of guide the viewer. I want the volume light to come in, shine on the Crocostrich. I want the rest to kind of recede into shadows, et cetera, et cetera. So with the magic of light filters, light linking, and some LPs, we can get something a lot more compelling than an R25. And this frame rendered in about 5 to 6 minutes. So the Crocostrich is a super cool asset, again, by great artist Victor Bessart, and you can check out his work there, and you can download his great asset from the Houdini documentation, in RenderMan. So aces, displacements, all kinds of amazing things. And shot lighting doesn't really end only at rendering. It truly also is, how do you manipulate things? How do you interact in the viewport with the tool in RenderMan? And we've made some good advances in redoing the manipulators for portals, for light filters, and all kinds of things so that you have a reasonable way to work with all these tools. Another, we have so many little kind of footnotes, but another one, amazing thing is the mesh lights, which is a really important thing for production. And we were waiting for the USD teams to actually align and be able to describe that for Solaris. And the side effects team has been amazing in implementing that in a new version. With that segue to Solaris, I really want to kind of understand who's here by raise your hands ever worked with USD or knows what it is. Okay, a couple. All right, so this is going to be great. So USD is a platform that's a scene description, basically, and it's evolved into a lot more than that. It can describe so many more things now. They're down the hall. We love them. We interact a lot. And the side effects team has done an amazing, amazing thing, which is to grab these technologies and put them in Solaris in a very kind of first-class, Pixar-oriented manner, and it's really brilliant. And to kind of see it in action, our green blob here, which looks very bizarre at first, but you'll start seeing the power of it, is you can't really do this in OpenGL. And I can tell you this because we tried at Pixar, and apparently loading hundreds of thousands of assets, individual pine needles, and billions of polygons will kill the nicest machine available. So USD allows us to do all this, to do transparencies, to do all kinds of sophisticated culling, sub-Ds, creasing, and zoom in up to a single kind of piece of chip there. So it's really brilliant, and we're excited that the outside world can finally play with USD, not only as an export tool to a program. So with this, when I was learning about all this stuff and trying to get out of my comfort zone from my software, I was falling in love with Solaris. And one of the things I did was grab my old robot room project from RenderMan 21 back in the day. And I've been trying to render this in XPU for years, but it was falling apart because we weren't there. Like, we didn't have the sophistication needed to actually render that old wrist scene. And this is a pretty complex scene, a bunch of textures and all kinds of sub-Ds and scattering and volumes and particles and lens effects. And like a weird diss, what I'm going to say, but it's literally the shaders of those studios. So one is the shader of Disney, and one is the shader of Pixar. Now, besides that, the technical differences of them are quite large. The Disney shader is a much more simplified approach to the BXDF. And Mark here can probably correct me as if they're still using it. I'm not sure if that's the exact, they are. Okay, so we have a legacy version of Pixar Disney, but we have a new one called Pixar Disney BSDF, I believe. And that's the newest and greatest. And that one is a lot more sophisticated, but nowhere near close to Pixar Surface, which is really this giant monolithic thing that can do anything. Pixar Disney is a little bit simpler, but easier to manage, if that's any help. And they are both supported. Yeah. Anybody else?
Other questions? Yeah. One sec.
Are you allowed to tell us when the next art challenge will be?
We will premiere the next art challenge on July 31st at SIGGRAPH. And we have some really interesting insight on what it likely will be, but there's nothing yet to announce. So, yeah.
Thank you.
You got it.
Stay tuned.
Stay tuned, yeah.
Any other questions? Well, thanks very much, Leif. Great work.
Thank you, guys.